Okay guys, so today we're learning lesson 9-2. You still need to take notes, and remember you can still use those notes on your quiz and on your test. So keep these notes in your spiral or in a binder, keep track of them, still take them even though we're not having you submit them. And then at the end of the lesson, you still need to complete the Schoology homework check. For today's lesson, you'll need some pieces of paper. So I cut up a sheet of construction paper into like little squares. So you'll need a sheet of paper. You're going to need up to 21 little sheets of paper. So let's go ahead and get started. Okay, so today we're learning lesson 9-2 on page 419, and it actually is the 22nd. All right, so you should have your little sheets of paper. The first activity, you actually just need 12 of them. So make sure you count 12. Okay, now with your 12 little sheets of paper, we're going to go ahead and put them into 3 groups. We're going to put 6 in one group, four in another, and 2 in another. Okay, so we have 3 columns here. 6 in one group, 6 in one column, 4 in another, and 2 in another. All right, today we're talking about the average. So we want to find the average of the numbers 6, 4, and 2. So we have 6, 4, and 2. If we were to put the same amount of little sheets of paper in every single column, you can't add a column, you can't take a column away, how many sheets of paper would there be? Well, since this one only has 2, I'm going to go ahead and take from this one and add it here. Now it has 3. Well, this one has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4, and this one has 3. I want them to be the same. Okay, so let's take one from here and put it here. Now this one has 1, 2, 3, and 4. This one has 1, 2, 3, and 4. And this one has 1, 2, 3, 4. So I evenly distributed my sheets of paper. So I had the numbers 6, 4, and 2. If I were to take those 3 numbers and give everybody the same amount, everybody would have 4. Let's do that again with our sheets of paper. Still with 12. Go ahead and put 8 and 1 in one column. 8 in one column and 4 in the next column. We're only going to have 2 columns here. So 8 and 4, we want them to have the same amount. We can't take a column away. We can't add another column. So we're going to evenly distribute these 12 sheets of paper into 2 columns. You might already be thinking in your head, well, if I have 12 sheets of paper and I'm splitting it into 2, then each one's going to have 6. Let's see. If I take one away there, now I have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. I need to take one more away there. Now I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They both have 6. So 8 and 4 evenly distributed, they both have 6. Okay, for this next one, we're going to make 4 columns, 2 in one column, 2 in the next column, 7 in the next, and 1 in the next column. And we want to have the same amount in every column. We have the numbers 2, 2, 7, 1. We have 12 total cards. So take some from the one that has the most and give it to the least. Okay, 2, 2, 2, but this one has 1, 2, 3, 4, 5, 6. So let's do that again. Now they'll all have 3, and they all have 3. So if we had 12 cards in 4 spots, spread it all out, they each have 3. Let's do that again. Now you'll need 20 cards. Now with your 20 cards, go ahead and make 4 columns, one with 4, another column with 1, another column with 8, and another column with 7. Okay, so 20 cards in 4 columns, you're maybe already thinking about smoothing out that data, evenly distributing out those cards, and how much would go in each one. Let's take from the one that has the most, give it to the least. Do that a couple times till we can smooth out this data. Now, ideally, I would have these cards really spread out, but just with the limitations of the camera height, you can't, I can't have them too spread out. So this one now has 4, this one now has 4, but this one still has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I'm going to take 1 from each of those, give it there. Now they all have 5. So if I smoothed out that data, 20 cards divided into 4 spots, they each have 5. Let's do this one last time, and for this last one, you're going to need 21 cards. Okay, so I added a card, now I have 21 cards, and you're going to make one row have 3, another row have 10, or column, 4, another column have 5, and another column have 3. Okay, now 21 cards, 4 columns, you want to smooth out that data. Go ahead and see if you can pause the video and figure out how you would smooth that smooth those, that data, evenly distribute those cards. So at this point, you should have taken some from the 10 and given them to the smaller ones for sure. So now I have 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. I'm still going to give them there and there. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. I have 1 extra. What can I do with this 1 extra so that they all have the same amount? I could tear this into fourths. So I'm going to tear this into fourths and give each of these a fourth. Now they all have 1, 2, 3, 4, 5 and a fourth. 5 and a fourth, 5 and a fourth, 5 and a fourth. So if I have 21 divided by 4 into 4, if I evenly distribute it, they all get 5 and 1/4. Okay, so what we were really doing by doing that Post-it note activity, we were really finding the mean. The mean is the average. We were evenly distributing all of those. So what you do to find the mean, yes, you could do the Post-it note or that little activity every single time, but if you have numbers of finding the mean of 100, 600, 500, I wouldn't want to do those every single time. So the way that you do it is you add all the numbers, add them all up, get the sum, and then you divide by how many numbers there are. That's how you find the mean. So let's do an example here. If we have the numbers 8, 5, 6, and 9, so you maybe are thinking about it with our activity here, you would have 4 columns, 4 numbers, 8 and 1, 5, 6, and 9, and you want to evenly distribute that into 4 columns. So let's add all the numbers up. Let's find the sum. We need to add all the numbers up. 8 plus 5 plus 6 plus 9, and then we're going to divide that by however many numbers there are. Or you can think with our Post-it note, our activity, how many columns there are. We're going to divide that by 4. We're sharing all of these into 4 columns. So when you add it all up, you get 28 divided by 4 is 7. So the average is 7, meaning that if we were to share all of these 8, 5, 6, 9, every single one would have 7 in each spot. 7 is the average. When we take your grades or your quarter averages, in Schoology, your grades are your average, those quarter averages. We're taking all of your grades, adding them all up, dividing by however many grades you have, and then that's your average. That's the representation that shows how you do. Sometimes you score really, really high on things. Sometimes you have lower grades, and then every number affects the average. Okay, so today we're talking about the mean. Tomorrow we'll talk about the mode and the median and the range. So here's a little song that I'll introduce today, and we'll keep singing again tomorrow to help you understand and just keep track of what these words mean. So you can sing it along with me. I'll sing it one time. You can sing it along with me the next time and keep on going. Mean, the average, mode, most often, range, subtract the smallest from the largest, median, the middle number, when you line them up from the greatest to the least. Cha-cha-cha. So that's just a song to help you remember what the mean is, the mode, range, and median. So let's sing it one more time. You can sing it with me together. Mean, the average, mode, most often, range, subtract the smallest from the largest, median, the middle number, when you line them up from the greatest to the least. Cha-cha-cha. So again, today we're just talking about the mean today, the average. You can think of it as the meanest type of problem because it requires the most amount of work. It's the mean problem, lots of computation. If we have these numbers here, let me write them down for you. Okay, so say this is the number of text messages that some friends send over the past week. Somebody sends 120 text messages, somebody sends 95, 101, 125, 82, 108, and 90 text messages. What is the mean number of text messages sent? So what's that asking? It's what's the average number of text messages sent. What is the biggest number here? The biggest number is 125. The smallest number is 82. So you know the average has to be between 125 and 82 because it's going to be the middle the average if we evenly distributed all of those. So it's in between those two there. So in order to find the average, we have to add them all up and then divide by how many numbers there are. When we add them all up, let's add them all up. 120. Okay, when you add them all up, you get 721. Then we divide 721 by however many numbers there are. 1, 2, 3, 4, 5, 6, 7. If you forgot and you were like, oh, I added them all up, 721 is my mean, that does not make sense. It's not between 82 and 125. It doesn't make sense that every person sent about 721 text messages when nobody sent over 125. So don't forget to divide. It's 2 steps. Add them all up and then divide by however many numbers there are. 721 divided by 7. 7 can go into 7 once. 7 can't go into 2, so remember I have to put that 0 up there. I can't just automatically bring down the 1. I have to put that 0. And then 7 can go into 21 3 times. And I'm finished. So your mean, your average is 103. Everybody sent around 103 text messages. For this next example, I'm looking at example 2 in your book on page 421. So the question says the double bar graph, there's 2 bars for every month, it's a double bar graph, shows the monthly rainfall amounts for 2 cities over a 6-month period. Compare the mean monthly rainfalls. So here's the rainfall. These are our months, November, December, January, February, March, April. And this is the amount of rainfall in inches. And we have 2 cities. City A is the dark green and city B is the light green. So you can see the 2 different cities. Dark green is A and then light green is B. We need to find the mean monthly rainfalls for each city so we can compare those. So to find the mean, we can follow their work here. They took every data point from city A, so 3.5, 2.2, 1.9, 2.1, 2.5, and 3.4. So to find the mean, you add them all up and then divide by however many data points there are. There are 1, 2, 3, 4, 5, 6. So city A would get 2.6 inches of rain on average. City B mean, you add them up, 1.7, 1.6, 2.2, 2.1, 2.7, 1.7. Divide by 6, because again, there are 6 months that they did it for, and you get 2. So now you can compare the monthly rainfalls and see that City A had more, averaged more rainfall than City B. Now that doesn't mean for every single month City A had more. Yeah, City A had more for November, yes for December, but not for January. Just on average it has more. They had the same in February, a little less in March City A did, but then way more in April. So you can see that these large numbers that had way more helped bring that average up for City A. Okay, let's look at these two questions together. So is the mean always equal to a value in the data set? So think about that answer, yes or no. Is the mean always equal to a value in the data set? Up here is 2 and 2.6. Are those actual numbers in the data set? No, it's not. It doesn't necessarily mean that it's going to result in one of the exact numbers. So the answer is no. Explain why the mean describes a typical value in the data set. So it might not be an exact value, but it describes a typical value. And the mean describes the values when it's evenly distributed. Think about that activity that we did at the very beginning, because you're evenly distributing all of those numbers into each slot that you have available. That's what you're doing when you're doing the mean. You're evenly distributing. The other part of the lesson today is talking about an outlier and how that affects the mean. So what is an outlier? Think of somebody who's like an outcast, right? They're kind of left on their own. So an outlier is a data value that is much less than or much greater than all the other values. And it affects the mean by either increasing or decreasing it. Say that these were somebody's grades. They got a 90, an 82, an 87, a 93, an 89. So they're probably hovering right around a B plus, A minus, right around that age. Right around that range, that grade. So what if they forgot to do an assignment and they earned a 0? They didn't do a homework assignment, they didn't complete something, they earned a 0. What does that 0 do to their grade? It drastically decreases it, right? It brings all their grades that they've worked really hard on down. This is an outlier. It is a value that is much less than, in this example, much less than all the other values, and this would decrease the mean. So that would be an outlier, and that would decrease the mean. Let's do another example. Okay, so say these are your grades in another class. You have an 80, 83, 79, 84, 80, so you're right at probably a low B. And then you really worked hard, you studied, you were prepared, and you earned a 98 on a test. What is that 98 going to do to your average? Yeah, it's going to increase your average. Okay, it's going to bring all of your other grades up. Once you get that 98, you'll see your grade goes up. This is an outlier. That's an outlier because it's much greater than all the other values. And in this example, it's a good thing. It would increase the mean. So you can see the effects that numbers have, or outliers have, on the average. Here, if it's super, super low, it would decrease. Here, if it's higher than all the others, pretty drastically, then it would increase the mean. So you can see the difference that an outlier has on the mean. Okay, let's look through this example. It's example 3 on page 422. Let's look through this example together. The table shows the heights of several Shetland ponies. Describe how the outlier affects the mean. Then use the data to answer the statistical question, what is the height of a typical Shetland pony? So here are all the heights in inches of Shetland ponies. We have 40, 38, 37, 38, 39, 37, 40, 28, 42, and 40. So is there one pony that is noticeably different in size from the others? Yes, there's one pony, you're looking at the numbers that you can see, that's 28 inches in height, so it's much shorter than all the other ponies. Now, you might be able to see that just by looking at this and kind of comparing those numbers and see. If you have a harder time seeing that, you could make a dot plot and see that, whoa, the outlier is way over here. Most of all the other data is clumped right here together. So that is the outlier. That's kind of to show you what it looks like, that it's super far away from all the others. You don't have to make a dot plot to see the outlier. This is just showing you visually how it looks when it's plotted. Now, to show you the effect that an outlier could have on a mean, they calculated it for you to show you. So if you calculated the mean with the outlier, that means you're including it with the outlier. So you're adding every single number and the 28. When you add all those numbers, they got 379, and they're dividing it by however many total numbers there are. There are 10 total numbers. So 379 divided by 10 is 37.9. Then they found the mean without the outlier. So they are going to take that data point out. When you take that data point out, you now have 9 numbers that you added. So you add all those numbers up, 351, and you divide now by 9 because you took that outlier out. So now your average is 39. It would make sense comparing these two averages that this one is much higher because you don't have that low outlier that's bringing that average down. That low outlier would affect the mean by decreasing the average. And you can see that right here, how it did that. It decreased that average, 37.9 compared to 39. Okay, so hopefully now you're comfortable with finding the mean, getting the mean, finding the average, and then seeing how an outlier affects the average by either increasing it or decreasing it. And we saw mathematically how it can make that much of a difference on the average. You go ahead and complete your homework check, your homework Schoology check for lesson 9-2. Mr. Chine and I will be on the Schoology conference if you have any questions. I can also start a Zoom conference if you all have any questions and want to work through some problems there together. So just contact us through the Schoology conference and you are ready to go. Thanks, guys. Don't forget the song. You can practice that song. It will come back next lesson as well. So you want to sing that song to help you remember what the mean, mode, range, median is. Mean, the average, mode, most often, range, subtract the smallest from the largest, median, the middle number when you line them up from the greatest to the least. Cha-cha-cha. I'll leave you with that. Bye.